Hello, everybody. Welcome to AkzoNobel's presentation, Better the Devil You Know, How to Avoid Tank Lining Failures. My name is Mike O'Donoghue. I'm a chemist working for AkzoNobel for over 35 years now in the field of protective and marine coatings. Together with my friend, colleague, and co-presenter today, Vijay Datta, we have written over 70 papers, many of which deal with tank linings.
And I'm the co-speaker with Mike O'Donoghue. My name is Vijay Datta. I have a master's in chemical engineering from New Jersey Institute of Technology. I joined the company in 1971, and right now I have about 49 years of experience in the marine and protective coating business. Along with Mike O'Donoghue, we have authored over 70 technical papers related to protective and marine coatings.
Facility owners with above-ground storage tanks understandably want their tank linings to perform well for some 20, 30, 40 years or beyond. Our quest today is all about adopting a proactive approach to avoid and prevent tank lining failures, and we'll focus on certain critical factors necessary to do this. This is not, however, about a reactive approach to rectifying tank lining failures once they've occurred. Now, for the owners amongst you, the engineers, applicators, coating manufacturers, and inspectors, when it comes to tank lining failures, it really is a case of better the devil you know than the one you don't. Throughout this presentation, you'll see several references for further reading, plus acknowledgements to some good folks who have given us some good JPEGs.
The journey, what we're going to be talking about here today. Thank you, Mike. Especially what we're going to present here is a snapshot of a journey where we will learn how to carry out a successful tank lining job. In the introduction, we will see why we lined the tanks in the first place, as well as review the history of the tank lining and typical challenges we face with them, especially in the oil patch. In addition, the use of thin and thick film tank lining will be touched on, and most importantly, we will touch on the performance expectations of asset owners and how to accomplish their goals. Folks, I bet you're laughing looking at this slide. This is, by the way, the swimming pool in my backyard, and I needed a repaint job. So I gave the job to the lowest bidder. Look at this very innovative scaffolding and also the very innovative human equivalent of the airless. And I love the junior painter over there. Looks like they did a pretty good job, but I don't know how long it's going to last. Let's see.
That's funny, Vijay. I love it. On a serious note, here's the lining breakdown costs that we could imagine for an above-ground storage tank. In a nutshell, the lining material for the tank floor and 3 feet up the shell is about 15% of the total project costs, as is the lining application itself, being 15% as well. As far as the surface preparation is concerned, it has within it abrasive blasting, purchase of the abrasives, labor, fuel, diesel fuel, inspection, and so on, and that constitutes about 70% of the total lining cost.
So the question is, why we line the tanks in the first place? Normally, a lining can be considered as a barrier between cargo and a substrate and must be suitable for a particular operating environment. So our main goal is to protect the substrate from the corrosion caused by the cargo. In this case, crude oil storage tanks are normally painted tank bottoms and about 1 meter up on the sides because they usually contain water, and that's what causes the corrosion. For aggressive chemicals, the entire tank need to be painted for protection. Second reason, we line the tanks for product purity. This could be against corrosion products from the tank as well as any material leaching from the lining itself. And the last reason to line tank is to protect the material integrity, as some of the chemicals such as ethanol can cause stress cracking at the welds. In this slide, we'll talk about a variety of applications for the linings. As you can see here, you can have water or wastewater tanks, crude oil tanks, which can also carry crude oil or refined petroleum products like gasoline, jet fuels, solvents, which could be like ethanol, methanol, or ketones, or other aggressive solvents, caustic, especially like sodium hydroxide at various concentration and temperatures, and then the acids, organic or inorganic acid. Just to give you an example, for the potable water, we may require NSF certified products, and even for some of the petroleum products, we may need lining with certain certifications. These are the various variety of applications for the linings, and like I said, we will need special lining for each area. Folks, look at this graph. This gives you real chemical resistance tank lining history. The graph shows the development of lining technology. Way back in the early 50s, we used simple bisset type linings, which could be cross-linked with polyamide or simple amine curing agent. The prime reason was, at that time, the cargoes were less aggressive along with relatively low storage temperature. As the need to carry more aggressive cargoes arose, there was a need to develop more robust chemical linings, and the chemists explored the use of epoxy phenolics, Novolacs, vinyl esters, Novolac vinyl ester technology. The latest invention is the use of polycyclamine cured phenolics and epoxy, Novolac epoxy coatings. They can handle very aggressive cargoes even at high temperature. These coatings could be solvent-borne or solvent-free. So this is in general the history of the tank linings. Now Mike, tell me, you spent a lot of time in the oil patch. How severe are the conditions there? And could you tell me why?
Vijay, there are so many demands placed on linings once they're put into service in the oil patch. With the steam-assisted gravity drainage, SAGD, and cyclic steam stimulation, CSS processes, we have to deal with all sorts of combinations of hydrocarbon liquids, lots of salt, temperature, H2S, CO2, acid gases, oxygen, water. There are what we're going to contend with. Pressures in some of things like free water knockouts, separators and treaters. It's really very, very difficult to deal with. And then when we're looking at abrasive blasting the steel substrates for the linings, you've got chlorides and sulfates, maybe some nitrates, the soluble salts to contend with, and then insoluble materials like sulfides especially, which could be galvanic to the steel. And you have to think about the organic acids and perhaps the performance enhancement chemicals that might be in the brew somewhere. So much to contend with.
That's a very interesting slide. In the past, we always dealt with the light crude where the coating only needed to handle low temperature oil. Thin and thick film bisset epoxy could handle the low temperature crude, as I mentioned before, but as the temperature progressively rose in the oil patch, the need grew for phenolic epoxies and then Novolac epoxies. As you can see, the temperature rose there, and then there was a need for the epoxy, Novolac epoxy coating, and on the thick film side, there was a need for the Novolac epoxy coating. Now with the temperature going over, well over 212 degree F, the Novolac thin and thick film epoxy really dominate the market use at this point, And then later on, we'll tell you what are the benefits of using thin and thick film coatings.
The choice of a lining system is very much dependent upon the condition of the steel, ranging from slightly pitted all the way to severely pitted. If we take a thin film multi-coat system of epoxy, for example, at 8 to 20 mils DFT, that will handle very beautifully both the zero pitting, light pitting, but not so much the moderate pitting. If we take a solvent-free epoxy or a glass reinforced epoxy coating system that's 60 mils, whereas the solvent-free is 20 to 40, Each of those lining systems will handle the zero pitting scenario as well as the light pitting and moderate ones.
Thanks, Mike. Severe corrosion pitting can give rise to significant steel loss. Here, for severe pitting, we can use fiber reinforced system, which can be applied to repair the steel. Their coatings are normally solvent-free and can be applied at 60 mils plus. If the structure is too weak, as you can see on the bottom of the slide there, no coating is recommended and steel has to be replaced.
For you rock and roll fans who appreciate the Rolling Stones, what are they going to do to help us here? Well, on July the 4th, 1969, Mick Jagger and Keith Richards sang these great words: "You can't always get what you want." Well, in light of the tanks that we're talking about today, we have to see whether they're right. Well, we certainly don't want to see this, do we? Believe it or not, this is a one-coat solvent-free epoxy tank lining that was just 2 years old when the WAC, it's called a weak acid cation tank, was opened up. It had blistered throughout the tank. There were several areas of delamination inside. There wasn't really much corrosion in there, but the expectation from the owner, everybody in fact, was for a minimum of 12 years performance. Now, what made us scratch our heads like infernally was the fact that the lining had been selected based upon a #1 ranking in a major third-party independent test. The application was good, everything was fine. The lining had been tested individually in acid, alkali, and the oil water media that goes into that tank under low constant temperatures, isothermal conditions. But in the real world service, it failed. Why? Well, it's because what's going on in the real world was a cyclic condition where the coating was stressed repeatedly with acid, alkali, and the oil water media, not so in the lab. It was a clear case where the lab tests did not correlate with a real life service.
Mike, we don't want this either, What constitutes a failure here in this slide? In these pictures, we see evidence of corrosion, blistering, delamination, either exceeding a record window or maybe the coating has been applied over a main blush, cracking, loss of adhesion. So what we see here is a significant roof corrosion, which certainly was not anticipated. We didn't even anticipate the delamination of a solvent-free epoxy and blistering of the solvent-free epoxy coating. So there are a lot of reasons why these things happen, and we will examine that, how to avoid these.
How about the thorny issue of tank design? If we have better tank designs, we'll have less coating failures, lining failures. Not to demonize the inside of these tanks, but you'll often have miles of heating coils 2 feet above the tank floor, and the applicator has to get underneath there to spray apply at typically 45 degrees the lining that has been specified. This is not easy. Yes, it's more conducive to multi-coat thin film systems than the solvent-free ones, but it's still very, very difficult. So the issue of tank design is also important to prevent coating failures. Let's take a look at risk in terms of cost of failure. At the 12 o'clock position, owner, 3 o'clock specifier, 6 o'clock the contractor, general contractor, the 9 o'clock positions. Let's go around and look at them from the owner's perspective. If he has a tank failure, you could lose $500,000 a day. The tank contents might have spilled out from corroded steel. It could be an expensive environmental disaster going on there. As far as the specification is concerned and the specifier, the specification must be fit for purpose, otherwise premature failure. Coating specifications are often built on inappropriate use of irrelevant test data, and that can lead to dark consequences. So the specification authority must get it right and with the appropriate lining for the oil-filled environment in question. As far as the contractor is concerned, he must have a good reputation, be experienced with lining applications. His men, ladies, whoever are doing the work, resumes of the blasters and applicators must reflect excellent workmanship on their part. He must avoid high and low DFTs, do the surface preparation properly, remove contamination. A whole host of things can go wrong there in terms of the cost of failure. And over at the position where the general contractor fellow's sitting, he can pull his hair out, lose millions of dollars a day on a job that can go wrong. I know this sounds dreadful, but it is pretty bad. So, for you listeners out there, I have a question for you. Who do you think are most responsible for coating failures? Do you think it's the applicator? Do you think the coating manufacturer is largely to blame? And I'm talking the coating failures in terms of lining failures in a tank. Who do you think it is? Lo and behold, if we break down the group and the responsibility, we'll see that owners and specifiers, engineers, they account for over 50% of the responsibility for coatings and linings that go wrong, mainly from delamination or from blistering. The coating manufacturers, 16%, contractors, 27%. That maybe is surprising with the contractors because most people would normally think contractors are responsible for about 70% or thereabouts of lining failures and coating failures, etc. And even the little old inspectors down there at 5.5%.
Mike, you said it right. It's all about people. Look at this slide. It's really, really interesting along with the previous slide. In the previous slide, Mike discussed the various groups who are responsible for causing coating failures. Folks, look at this slide very carefully. There are two studies done, one in 1993 and the other one in 2000. What do you see the difference here? Please note the findings. The key parameter which has escalated for the coating failure is incorrect specification. I mean faulty specification. It went from 19% to 41%, whereas all the other areas almost remain the same. The application error went down from 68% to 46%, probably more training to the applicators and using experienced applicators.
Here we see the services that might be required in the event of a very nasty tank lining failure. At the bottom of the x-axis there, document review and the site visit. That's not very expensive, moving up from testing and analysis through reports and negotiation, and the cost is increasing all the time up to legal support. So this is not what we would like. It might be what you might need. Harking back to the Rolling Stones, you can't always get what you want, but if you try sometimes, you just might find you get what you need. And what do we need? Predictability in this little quality fidget. We need specifications that are high quality, as well as contractors experienced and good reputation, as we said earlier, and we need excellent quality inspection, typically third-party independent inspection when we're doing tank lining projects. But when it comes down to inspection, we need good common sense.
Here there are some key factors for a successful lining application. As you can see, there are 5 parameters which I have been describing here. And you can see here the first one is the scope of the work. We must define what we're going to do. What is the scope of the work, And after that, we need to have a very robust and good specification. Specification must tell you selection of the proper tank lining, how we're going to apply it, what are the min-max DFTs, and after that we must be choosing a very quality contractor. He should be very experienced in the application of the tank lining. And after that, the contractor must also be able to provide an inspection testing plan. How is he going to inspect the coating applications? So after that, before we really carry out the lining applications, we must have a pre-job meeting with all the parties involved, manufacturer, applicators, the owners. We must define the do's and don'ts for a successful application of the lining here. I mentioned in the previous slide problem with the inappropriate or poor specification. Too many coating projects end up being classified as failures because the specification writers suffer from what is sometimes called the Xerox syndrome. And we're going to talk a lot about that. Simply stated, that means the writer takes out an old specification and changes the wording to reflect a new structure without really understanding the complexity of the painting that structure in the specific location at the specific time of the year. Now take a look at it here. I'm going to talk about the three scenarios here of the specification. First one is conventional wisdom specification. Typically initiated and discussed at trade organization committees. We all do that, where we meet with the participants, provide anecdotal experience of our performance, which are often then crafted into a specification. These experiences do not necessarily show any evidence of actual utility. The problem with these anecdotal experiences are they are not necessarily based on any scientific principle or verified using scientific methodology. They are at times widely inconsistent in their application. Second one, hand-me-down specification. What are these? These are specifications developed in some past years and applied year after year without any review of updating or improvements. There's a lot of technology improvements, but nothing has been updated here. Oftentimes, due to personal changes in any organization with the incoming personnel, not sufficiently skilled people review these specifications and suggest improvements or comments. The last one, that's my favorite. This is the common use specification. Specifications that are used over and over again, different users because they exist, provide results, and are rationalized by if they're good for them, they're good for us, without this actually being true. Now, Mike, we have talked quite a bit about the specification problem. Is there really a better way of coming up with a specification? Please tell me.
Thank you, Vijay. The bottom line is we need relevance as far as specifications are concerned for the particular lining application. And the specifications are going to be predicated on the idea that the specification writer is going to know full well what's best for the owner. You can have all sorts of testing protocols in the lab. You can do work in the field. So you compare and contrast. This is a good way. It's a focused approach, a focused methodology to get good coating specifications drafted and trying to mimic what goes on in the laboratory with what you find going on in the field conditions.
Thank you, Mike. Let's discuss what we need to include under the quality specification. Number one is the environmental condition, whether the job is going to be done in the shop or in the field. What are the temperatures? Is it a winter time or is it a summertime? Pre-cleaning and surface preparation of the steel. Now this is the foundation for the whole job. We must have a very proper surface preparation. Stripe coatings, specific film thickness and its measurement. What are the minimum low and the maximum high as defined by the coating manufacturers? Some of the touch-up procedures. Quality control, how are we going to measure the quality of the applied coating? All these parameters must be included for the quality specification.
A legend in the protective coatings industry, like Clive Hare, here is the late, great Mark Schilling, famous for debunking much in the world of the salt frenzy. Writing about specifications, Mark was at pains to point out that the differences in a generic type of coating, such as epoxies, can be like chalk and cheese. Resins with similar backbones do not necessarily give the same performance at all for lining applications. So caveat emptor, buyer beware.
So now, how are we going to select the correct lining? There are a lot of things we need to know before we can really make a recommendation for the lining. We need to know the chemistry of the cargo. What are the cargo we're going to carry? What are their concentration? What are their temperatures? Do they contain really any solid particles which can cause abrasion? How about the tank design? Condition of the steel. Is it a pitted steel? Is it a brand new steel? And then, of course, the life expectancy and the expectation from the asset owners. What is the return to service? Does the owner really want to put the tank back into service very quickly? And what is the application method? Are we going to apply by airless spray, pour component, or brush and roll? Those kind of things we must know before we can select the correct tank lining. The next one is the quality contractor. We should do it once and do it right. We must have a quality contractor who is experienced, who have the right equipment to do the job, and he should be able to carry out the job in a timely manner. We must have a pre-job meeting with the contractor. He should have us spray out a small piece of steel just to make sure the coating is being applied at the right film thickness. Quality contractor must have the right equipment for the application of the lining. He must mix the paint in the proper ratio, apply the coating at the recommended dry film thickness. All other parameters such as use of the proper thinner, recut window, etc. must be followed per coating manufacturer's instruction. Surface preparation is one of the key parameters to avoid any tank lining failure. After blasting cleaning, some of the key items to pay attention to are: is there any evidence of pitting? Are there any holes on the substrate? How about the contamination? Dust residue, etc. must be removed prior to the application of the lining. Another thing we need to pay attention is, are there any markings on the steel after blasting? Those markings must be removed, as most of them are very water soluble and can cause premature coating failure.
Corrosion pitting can be very problematic, especially with these omega pits, and may even lead to perforations in the tank bottom or tank shell. In particularly bad cases, repair is made by grinding or welding, patching or replacing the steel plates. But where plates remain after cleaning and abrasive blasting to SSPC, SP5, NAICS 1 standard, some owners nowadays are mandating that a solvent-free epoxy lining cannot be applied in a single coat application, and that's even if the pits are filled with a solvent-free epoxy grout. Instead, they prefer the application of a solvent-borne high-performance epoxy holding primer, and then detail the pits using a squeegee applied solvent-free epoxy grout before applying the solvent-free epoxy lining. We must avoid invisible enemies, and those are typically soluble salts, retained solvent in coatings, and so on, where we can end up with osmotic blistering, as you see evidenced here, and the cleaving of the bond between the steel and the epoxy. What's often not discussed, though, is the impact of insoluble sulfides, which, when they're broken up on a surface, can lead to all sorts of problems because the insoluble sulfides are cathodic to steel and the scourge of many industrial processes. So these are the invisible enemies. First and foremost, in our tank lining applications, we want cleanliness.
Surface preparation. Normally, for immersion service, we abrasive blast to an SSPC5 or SSPC10, depending on the cargo and the temperature. And we want to make sure that we have a very sharp angular profile, which for thin film coating is usually 2 to 3 mils, and for thick film coating is 3 to 5 mils. Now let's take a look carefully at the profile we have been talking about in terms of height, density, and shape. Now there are two scanning electron microscope micrograph pictures here, which are about 1,000 times magnification. The common practice is to use grit and shot together to get a very angular profile. The more the grit used, the more sharp and angular profile we're going to get. On the right hand side, you can see there is a very paint pattern, very smooth, which has been obtained by using only the shot, which gives you a very rounded profile, and that's the one we really don't want. Now, the steel substrate has a number of reactive sites to which the coating can chemically bond. So increasing the surface area by angular profile, you can double or triple the number of reactive sites and increase the chemical bond. So that's really is the most important thing here, is the height, density, shape, and the angular profile which we need for the chemical tank linings. So folks, in a nutshell, we absolutely have to make sure the surface preparation for the application is correct and the criteria we have been talking about, which is listed right here. We have to have a SSPC SP5 or SP10 for immersion service, depending on the cargo. We need to have a very angular profile with 2 to 3 mils profile for the thin film lining, and for thick film lining anywhere from 3 to 5 mils. The surface has to be very clean. The chloride level has to be less than 3 to 5 microgram per centimeter square, depending on the cargo and the temperature. And the other things like sulfates, nitrates also has to be dealt with and should be less than the listed amount here. Another very important factor here is we need to talk about is the striping of in the tank. That's very, very critical how to do the proper striping. Again, getting it right, do it once, do it right. Here you can see how to do properly where the stripe coat is just thick enough to cover the welds or any sharp areas. We do not want too much film thickness on these areas, and I'll tell you why. Stripe coats are applied mostly in the area where it's difficult to get the required coating coverage, like plate edges, weld, and difficult access areas. You don't want too much paint on the stripe areas. There are several drawbacks of putting too much paint, and I'll explain it in the next few slides. So in this slide, we can show you how not to stripe coat. As you can see, somebody did the striping with the roller and applied a lot of paint, solvent-borne paint, which can cause a lot of stresses in the coating. It can also give you very poor cross-link density. Cargoes can penetrate, can cause delamination here. So we need to avoid those and do the proper stripe coating. Mike, now, once we have done all this and there is some touch-up in the field, which can be another area of major concern to us, can you explain us what particular attention we need to pay on the field touch-up areas in the field?
And we don't want to see a situation like this, where the field crew have become formulators in the field, so to speak, and are mismixing the lining in the repair areas and any areas where there are deficiencies in the dry film thicknesses, for example. We don't want to hear, when we eavesdrop inside of there, that one of them says, don't worry about scraping that stuff off the side of the can. Or another person might say, well, this stick will do in measuring the 4:1 ratio. Or elsewhere, let's add some solvent. This stuff's too thick. We would hate to hear things like this, and we certainly shouldn't and wouldn't if we've got a very experienced crew and they know what they're doing. And that's one of the key quality predictability factors that we looked at earlier. The two components of our epoxy lining will have an optimum mix ratio, and we can often identify the level of any mismixing by examining chips of the lining sample versus deliberately mismixed lining samples that we prepare in the lab. Then, using infrared spectroscopy or elemental microanalysis of nitrogen in particular, we can determine the mix ratio of the field applied lining. In this case before you, using carbon to nitrogen and the hydrogen to nitrogen ratio microanalysis, the mix ratio of the unknown is seen to be 2.1. Epoxy linings may be susceptible to that greasy amine blush or the sweating because the excess of certain amines that comes up to the lining surface are good scavengers of carbon dioxide at high humidity and low temperature. And then they can form amine carbamates, and that's the haze that you see on the surface of this solvent-free epoxy. So during a multi-coat application process, the applicator should have been advised if the epoxy lining has any tendency to blush or sweat. And if this happens, if it's not carefully removed by washing or cleaning with a suggested 1:1 glycol ether water mixture, this clear and water-soluble blush, the surface contaminant you see here on the film, can lead to intercoat adhesion failure of a top coat.
Folks, Look at this slide where we really need a proper ventilation, which is very critical, not for the applicators only, but also for the coating's life. We have to remove the solvent vapors from the bottom of the tank. We all know that the solvent vapors are heavier than air, so they have a tendency to go to the bottom of the tank, and we must have the proper method for ventilation to replace those solvent vapors from the bottom of the tank. That's absolutely necessary to make sure the coating cross-link properly, cure properly, and provide the service it's intended for. Let's talk a little bit about the film thickness control in the tank lining application, which is very, very critical. As we all know, the performance of the lining can be affected by over and under application of the lining because it can lead to so many problems. Just a few which I have listed here are the cracking, solvent entrapment if you put it too heavy, which can cause very poor chemical cross-linking, improper curing, runs and sags. It can increase the dry time because you put it too heavy, the film thickness, and which can ultimately give you shorter service life. So we must pay particular attention to all these parameters here on the film thickness. What I would suggest is to contact the coating manufacturer, and they should give you the guidance on the absolute minimum and maximum GFT. Okay, Mike. Now, thus far we have dealt with the two of the three elements we require for predictability, that we'll get a good lining job and avoid lining failures. Number one is the quality specification. Number two is the quality contractor who's going to give a quality application to us. Now, Mike, tell us, third vital element to avoid tank lining failures.
Aha, VJ, my young friend. The third requirement of predictability for tank lining success and avoidance of tank lining failures is quality inspection. And just for a laugh, look at these fascinating characters looking for pinholes. There's a lot more here than meets the eye. Seriously, we want common sense and quality inspection from third-party independent inspectors. And by the way, you may be interested that the holding primer referenced here is a high-performance epoxy tank lining itself with equal or better chemical resistance to the thick film solvent-free epoxy that's about to be applied to it. The first thing we do as far as testing of the cured film is concerned is to check the lining at the entrance of the tank or vessel to ensure it has dried sufficiently to walk on and inspect. Then once inside, we look at the general appearance of the lining to ensure it's consistent and uniform and free of defects. And then there's a DFT check to make sure that the dry film thicknesses are in compliance with the manufacturer's requirements for the particular project.
Good job, Mike. And some of those coating defects, they include but are not limited to coating runs and sags, overspray, debris, air, or areas where the coating may not have flowed out well during the application. So we must need to remove all these coating defects. Following the visual inspection, we perform a dry film thickness test to ensure the dry film thickness is in compliance with the coating manufacturer's product data sheet. As I mentioned before, that's very, very critical for the successful curing and giving us the cross-link density of the lining is designed for.
A holiday test is performed on the entire lining to ensure that there are no discontinuities. Defects, particularly those that go right through the lining to the substrate, they can result in premature lining failure. Holiday testing will be performed according to the NACE standard SPO 188, and with lining films less than 20 mils DFT, low voltage wet sponge holiday detection will be used. Whereas high voltage dry spark holiday detection is going to be used for lining films greater than 20 mils DFT.
That is another important slide here, repair and return to service. If the coating is damaged, it has to be repaired, and we must get the proper repair method from the coating manufacturers. Just in simple, typically the lining is abraded to create a proper profile for the proper adhesion, and the size of the repair determines the application method. It could be just like a simple touch up with the brush, or it may, if the larger area, we may have to spray it. But we should always refer to the manufacturer's application guidelines for repair. If you don't have it, the contractor must ask the coating manufacturer to provide the repair procedures. Second thing is the consideration for return to service, which will very depend on the temperature of the substrate and the environment. The type of lining we have installed. Some linings cure much faster and can be put back into service very quickly. Others will take a longer period of cure time. So again, we need to contact the manufacturer for the proper information. Also, all the touch-up areas, repair areas, we must give proper cure time before we can put the tank back into service.
In closing, if you do it right, look what you can get. On the left-hand side is the appearance of a one-coat solvent-free epoxy lining installed in a tank 20 years ago. And on the right-hand side, how it looked 20 years later. Almost identical. So VJ, we began our journey with Better the Devil You Know, how to avoid tank lining failures. The devil is in the details. Small details about tank lining applications are just as, or maybe even more important than, big details about tank lining applications. And we can have predictability, quality specifications with quality contractors and quality inspection. We will assure success and avoid tank lining failures.
Finally, folks, if we can really have all these three elements, quality specification, quality contractor, and the quality inspection of the tank lining, we can all have a peace of mind.
And a big thank you from me, Mike O'Donoghue. And if you'd like to reach me at any time, please do so at the number there, 778-838-4538, and you can contact me by email. Thank you again.
Folks, thank you very much for paying the attention. And I bet if we do all these things, we can have a very, very successful tank lining. And here is our contact information. If you have any questions or you need to contact us, here is our email address as well as our phone number. Thank you so much.